Hello coders, I welcome you all. In this video, we are going to discuss our next machine learning project, water potability prediction using machine learning. However, this project is going to be different from other projects that we have performed. In this project, we are going to build a machine learning pipeline using DVC, data version control. Shortly, we will discuss DVC. At the end, we will create our API for this project using Fast API. So as you can see, in our previous projects, we have performed each step of the machine learning pipeline, such as data collection, pre-processing, feature engineering, model building, etc. in one file. In the industry, these parts of the machine learning pipeline are handled by different engineers. So it is better if we create separate modules. Modules means separate Python files to make it easier to maintain instead of writing code in one single file. So as you might know, in machine learning, all these steps, data collection, data preparation, feature engineering, model building, and model evaluation are connected in a pipeline manner where the output of one step becomes the input for the next step, right? So for each of these steps, we will create different modules, which means different Python files, and connect these separate modules into one ML pipeline using DVC. Let's first discuss DVC. DVC stands for Data Version Control. Is an open source tool designed to handle large data sets and machine learning models. It helps manage and version control for data and models in the same way that Git handles code. You can see here some key features of DVC: version control for data, data management, reproducibility, collaboration, and pipeline management. By integrating DVC into our machine learning workflow, we can manage our data and models more efficiently, ensuring that your projects are organized, reproducible, and scalable. We will discuss other features in upcoming videos, but in this video, we are going to focus on pipeline management, and we create a DVC pipeline for our machine learning project, water potability prediction. DVC pipeline allows the creation of data pipelines where each step, such as data collection, pre-processing, model training, etc., is defined as a separate stage. DVC tracks dependencies and ensures that each stage is executed only when its inputs change. Don't you worry, we will discuss it practically. You can get more information about DVC from its well-documented website that you can see over here. So now let's move on. First, we will create a data collection module for our project, which means a Python file for data collection, and add it to the dvc.yaml file. You can see here dvc.yaml. YAML. So as I said, we will first create a data collection module, means a Python file for data collection, and add it to the dvc.yaml file. Then we will create our second module, meaning the second Python file for the data pre-processing, and we add it to the same dvc.yaml file. We will follow this process for the other modules as well, up to model evaluation. We will add modules for data collection, data pre-processing, feature engineering, model building, and model evaluation to this file, dvc.yaml file. Here we call it as machine learning pipeline because we will build connections between all these modules. Don't you worry, we will discuss it practically. Now just remember, at this stage, creating a DVC pipeline means handling the dvc.yaml file. That's all. I am repeating, just remember, creating a DVC pipeline means handling this file, dvc.yaml file. We will create entries for each stage in this particular file, dvc.yaml, including the required inputs for the stage, the output of the stage, and how to run the stage in this file. You can see different stages: stage 1, stage 2, stage 3, stage 4, and stage 5. So we will create entries for each stage in this particular file, dvc.yaml, including the required inputs for the stage, the output of the stage, means what inputs required for this stage, what output will be generated by this stage, and how to run this stage in this file. So in the dvc.yaml file, each stage of your pipeline is defined under the stages key. Assume that it's a key value pair. Each stage contains three main elements. First, CMD, command to execute for the stage. DEPS, dependencies required for this stage, means input files required to execute this particular stage. Just remember, this dependencies parameter defines the connection between two stages and form a pipeline, right? This is how DVC establishes connections using this dependencies parameter between different stages of a pipeline, ensuring that the output of the one stage, means dependencies, can be used as an input for the next stage. And third, OUTS, outputs produced by this particular stage, means resulting files. So please remember, each stage contains three main elements. First, command to execute for the stage. Second, dependencies required for the stage, means input files required to execute this particular stage. And outputs produced by the stage, means resulting files. Again, I will show you this practically. At the end, we will run this particular file, dvc.yaml file, which will execute our pipeline stage by stage, from first stage to the last stage, one by one. Don't you worry, as I said, I will show you everything step by step practically. Before we move to the coding part, as you can see here, as usual, I have performed each step of the machine learning pipeline, such as data collection, pre-processing, model building, model evaluation in one single file. You can see Jupyter Notebook file. As you can see here, I have imported the libraries that we require. And in the next step, we have read the dataset as a pandas data frame and stored it inside a variable named data. In this particular step, as you can see, here we are displaying first 5 random rows from the dataset using the sample method. And in the next step, we are checking the shape of our dataset that you can see over here using this attribute of pandas data frame, shape attribute, right? Total, we are having these many rows and these many columns available in our data set. Here we are displaying information about our data set, like total number of rows, total number of columns, data types of each column, and memory requirement that you can see over here. You can see our columns and data type for each and every columns. As you can see in our data set, we are having 9 columns with floating point data type and 1 column with integer data type that you can see over here. And here we are generating descriptive statistics for the data set that you can see over here. Count, average value, standard deviation, minimum value, different percentile values, and maximum value that you can see over here. Here we are checking for the missing values. And as you can see here, in this particular column pH, these many values are missing. In this particular column sulfate, these many values are missing. In this particular column trihalomethanes, these many values are missing. And in the next step, we are splitting our data set into the training and testing sets. And as you can see, here we are keeping 20% of the data in the testing set that you can see over here. Our training data and test data. And here we are filling missing values using the median value of that column that you can see over here. This is the only pre-processing step we are performing here in this project, because in this project we are focusing on building a machine learning pipeline using DVC. So now next, just we have completed our pre-processing step, and here you can see model building. We have used only one classifier, random forest classifier, and here we are saving our model. So again and again training is not required. We can perform prediction using this saved model, and we are saving our model using pickle library. And in the final step, which is model evaluation, we are evaluating our classifier, random forest classifier, using accuracy, precision, recall, and F1 score that you can see over here. Hope all of you are clear with this. Now let's discuss our data set. You can see we are going to use this particular data set, water quality and potability. You can download this data set from Kaggle or from my GitHub account. Link is provided in the description of this video. So this data set contains water quality measurements and assessment related to potability, which is the suitability of water for human consumption. The dataset's primary objective is to provide insights into water quality parameters and assist in determining whether the water is potable or not. You can download this dataset by pressing this button, download button. As you can see, each row in the dataset represents a water sample with specific attributes, and the potability column indicates whether the water is suitable for consumption or not. Total, we are having this many columns that you can see over here. First, pH, the pH level of the water. Second, hardness, water hardness, a measure of mineral content. Next, solids, total dissolved solids in the water. Next, chloramines. Chloramine concentration in the water. Next, sulfate. Sulfate concentration in the water. Next, conductivity. Electrical conductivity of the water. Next, organic carbon. Organic carbon content in the water. Next, trihalomethanes. Trihalomethanes concentration in the water. Next, turbidity. Turbidity level, a measure of water clarity. And our final column, which is our target variable, indicates water potability with value 1 means potable and 0 means not potable. Hope all of you are clear with our data set. Now let's move to VS Code. As you can see, currently I am using my command prompt. Let's move to the drive and let me create one new directory with name ML_pipeline. Let me press enter. Let's move inside this directory ML_pipeline. Let me write one command, code space dot. This command code space dot opens VS Code in the current directory, means in this particular directory ML_pipeline. Here dot represents the current directory. Let me press enter. As you can see here, VS Code opens in this particular directory that just we have created. Now let me click on this terminal and let's open new terminal. Let's create new directory with name src. Let me press enter. You can see here, we have successfully created this directory src. Let's clear this. Now first we have to initialize git. So let's write command git init. Also we have to initialize DVC. So for that we have to write DVC space init. You can see here, we have successfully initialized git and DVC. That also you can see here. So please remember, first you have to install git, DVC and machine learning libraries. If you haven't installed in this VS Code, you can install DVC using this command pip install DVC. Now let me click on this folder src and let's create new Python file with name data_collection.py. This is our data collection module. So here in this VS Code, we will create 4 Python files, one for each stage: data collection, data pre-processing, model training and model evaluation, that you can see over here. Then we will join each of these files using DVC, that you can see over here. So now let's talk about our first stage, data collection, this one. So please remember, here we will create 4 Python files for our project. One file for each stage: data collection, data pre-processing, model training and model evaluation. Then we will join each of these files using DVC pipeline. Now let's talk about our first stage, data collection. So in our first stage, data collection, we will collect the data. In our case, the data is available locally. You can fetch the data from a URL if it is available somewhere on the internet, right? Now let's move on. After that, we will perform a train test split, which means we will separate our data into 2 parts, one for training and another for testing. Then we will create a folder with name data. Inside this folder data, we will create another folder with name row. And we will store our separated files that we have separated over here using train test split into this folder row with name train.csv and test.csv. Now let me show you this practically. Let's jump back to VS Code. As you can see, just we have created one Python file with name data_collection. So now let me import pandas as pd. Let me import numpy as np. Also let's import OS module. Also we have to import from sklearn.model_selection. Let's import train test split. Now let's read our CSV file, means our data set. You can see our data set that I have downloaded from Kaggle. Let me press this copy as path. Let me paste it over here and let's set it as a row string and let me assign it to one variable data. Now let's perform train test split. Here we are passing our data and let's set test size to 20%. We are keeping 20% data for testing purpose. And let me set random state to 42. Let's assign it to 2 variable, train_data and test_data. is equal to this statement. Now let's create folders using os.path.join data folder inside row folder. And again, let me assign it to one variable data underscore path. And to create these folders, we have to use os.make dirs. And here we have to pass this variable data underscore path. Now let's save train underscore data to CSV file. So again, os.path.join. Here we have to pass data underscore path variable that we have created over here and file name train.csv. And let's set index to false. Same we have to do for test data as well. To underscore CSV. os.path.join data underscore path and file name test.csv. Again, let's set index to false. So here we have done exactly that just we have discussed like this. We have created data folder. Inside we have created one row folder and we have stored our separated files with name train.csv and test.csv, right? Now let me run this file using Python just to test whether it is working or not. This is just to test, but actually we have to add this module as stage 1 of our pipeline using DVC stage add command. I am running this file using Python just for testing purpose. So let's move inside src and let's execute this file data underscore collection.py. Don't forget to save this file. Let me press Ctrl S and let me execute this file. You can see over here data folder inside row folder, and row folder contains two files test.csv and train.csv that we have created over here. So please remember, here we have set index is equal to false, means we are saving the data frame to a CSV file without the index column. If we do not set index is equal to false, an extra column named unnamed will be added to our CSV file. That will create some problem in the future when we will train our machine learning model. Therefore, using index is equal to false ensure that our CSV file is clean and contain only the data that we want to save. That's all. That's why here we are setting index is equal to false. Now we can able to run this particular stage data underscore collection.py. Now let's delete this. Now let's write the command that will add this module to the dvc.yaml file as the first stage. So for that, let me clear this. Let's come out of this src folder and let me write dvc stage add /n, our stage name, data collection, dependencies, src data underscore collection, dependencies, this file itself, output of this stage, data/row folder, right? And how to execute this module? Python, which is available inside src folder with name data underscore collection.py. So this way we can add this module to the dvc.yaml file as the first stage. Let's press enter. You can see here dvc.yaml file is generated automatically by this command. And let me click on this file. You can see here we have successfully added our first stage to our pipeline. So as we discussed, each stage in the dvc.yaml file contains three main elements. You can see cmd, command to execute for this stage, dependencies, dependencies required for the stage, means input files, right? And outs, outputs produced by this stage, means resulting files. Once we complete this entire pipeline, we will run this particular file, dvc.yaml file, which will execute our entire pipeline stage by stage. You can see this is dvc.yaml file. YAML stands for YAML Ain't Markup Language, which is similar to XML and JSON. YAML also contains key value pairs that you can see over here, but doesn't have text, making YAML more readable compared to the others. Let me clear this and let's execute this particular stage. Means let's execute our pipeline. But currently our pipeline contains only one stage, data collection. So for that we have to write dvc space reproduce. So this command ensures that all the stages of the pipeline are executed based on the dependencies and outputs defined in the dvc.yaml file. Let me press enter. So you can see we have successfully executed our pipeline, means our first stage of the pipeline. And as you can see, this directory has been created with name row inside this folder data, having two files, test.csv and train.csv, that we have created over here. You can see train.csv and test.csv inside row folder, which is inside data folder, that you can see over here. Let me clear this and please look at here carefully. Let me execute our pipeline one more time using this command DVC repro, means reproduce our pipeline. So you can see that when we run DVC repro command one more time, DVC will check for the changes in the dependency of each stage. If there are no changes in the dependencies, the stage will be skipped, means DVC will not rerun that stage, that you can see over here. Stage data underscore collection didn't change, skipping, that you can see over here. Now let's use another command DVC DAG. This command to visualize our created pipeline. DAG stands for directed acyclic graph, showing the stages and their dependencies. But currently we have created just one stage, data collection, right? That's why it is showing only one stage of our pipeline, data collection. So you can see we have successfully created our first stage of the pipeline. Now let's move on and let's create our next stage of the pipeline, data pre-processing stage. So you can see our second stage of our pipeline, data preparation, also called as data pre-processing stage. So in this particular stage, first we will fetch the train and test data from the row folder that we have created during first stage, data collection, right? So now you can see here, we will pass this folder row as dependency during second stage, data pre-processing stage, means output of the first stage becomes the input of the next stage, that you can see over here. So here we are making connection between stages and creating our machine learning pipeline. Hope all of you are clear with this. After that, we will fill the missing data using the median value of the column. After filling the missing data, we will create a new folder named processed inside the data folder that we have already created. And we will save our processed data with the names train underscore processed.csv and test underscore processed.csv inside this processed folder. Hope all of you are clear with this. Now let me show you this practically. Let's jump to VS Code. Now let's click on this folder src and let's create new file with name data underscore prep.py. You can give any. Now again we have to import these libraries. Let me copy this and let me paste it over here. Now let's read train.csv, which is available inside row folder train.csv. Let me assign it to one variable train underscore data is equal to this statement. Let me copy this and let me paste it over here. Same for test data as well. Now let's fill the missing values with the median value of that column. So for that, let me create one function, fill missing with median. And here as a parameter, we are passing data frame. So let me write for column in df dot columns. If df column is null dot any, if any missing value in this particular column, let's find median value of that column. And let me assign it to one variable median underscore value is equal to this statement. Now let's fill missing values using fill na method of pandas data frame median value, and let's set in place to true to modify our existing data frame. Now let's return data frame. Now let's fill missing values with median, means we are going to call this particular function on train data and test data. So let's call this function first on train data and test data. Let me save this file first. Let me press Ctrl S and let's assign it to one variable train underscore processed underscore data is equal to this statement, and test underscore processed underscore data is equal to this statement. So now let's create directories with os.path.join. So in data folder, we are going to create another folder with name processed as we discussed earlier. And let me assign it to one variable data underscore path is equal to this statement. And we have to execute this command os.make dirs. Here we have to pass data underscore path variable that we have created over here. Now let's save processed data to CSV files. Train underscore processed data, this one underscore CSV. And here we have to write os.path.join data underscore path, and let's give name train underscore processed dot CSV. Again, we have to set index equal to false. Let me copy this. Let me paste it over here. Same we have to do for the test data as well. Test underscore processed dot CSV. Again, we are setting index is equal to false. Let's save this file. So as you can see here, we are reading the training and testing data from CSV files located inside data/row folder. As you can see here, we are defining a function to fill missing values in the data set with the median value of that particular column. And here, finally, we save the processed data to CSV files in the data/processed directory that you can see over here. Now, let's add this stage as a second stage of our pipeline. So again, we have to use DVC stage add command. Again, we have to give name for this particular stage, pre_processing. And here we have to create dependency. First file itself, which is available in SRC folder. You can see our file name, data_prep.py. Another dependency, data/root. Now please concentrate over here. This is output of the first stage. Data collection becomes the input to this particular stage, data pre-processing. And this way we are building our machine learning pipeline using DVC that you can see over here. Now here output of this stage, data/processed folder. And how DVC will execute this stage? Using this command, Python src/data_prep.py. Let's press enter. You can see here we have successfully added our second stage to this particular file, dvc.yaml file that you can see over here. Let me clear this and let's reproduce our pipeline. You can see here we have successfully executed our pipeline. As you can see, this folder has been created with name processed, which contains two files, test_processed.csv and train_processed.csv that you can see over here. Let me clear this and let's visualize our pipeline. DVC space DAG. You can see this is our first stage and this is our second stage. First stage, data collection, and second stage, pre-processing. And you can see the connection between two stages that you can see over here. This connection has been created because of dependencies. Please remember this. You can see we have successfully created our second stage of our machine learning pipeline. So please remember, you can add modules like feature engineering as per your project requirements. However, in this project, we are not performing feature engineering. We are starting with model building as our next stage. So now let's create our next stage, model building. Now let's create stage 3 of our machine learning pipeline, which is model building that you can see over here. Stage 3, model building. So in this particular stage of our machine learning pipeline, we will first fetch the train_processed.csv file from the processed folder that we have created during stage 2. You can see here, again here we are making connection between two stages to form a pipeline, right? After that, we will train a random forest classifier on our data set, on our training data set. Because as you know, we are solving a binary classification problem. So that's why here we are going to use random forest classifier. After training, we will save our model using the pickle library. So again and again, training is not required. We can perform prediction using this saved model. After making stage 3 model building, we will create stage 4, which is model evaluation. So in this particular stage, which is our final stage, we will evaluate our classifier using accuracy, precision, recall, and F1 score. So now let's jump to VS Code and let's create our stage 3, model building. Now let's click on this folder src and let's create new Python file with name model_building.py. You can give any. Again, we have to import these libraries. Also, we have to import pickle library. Also, we have to import from sklearn.ensemble. Let's import random forest classifier and let's read our processed data, which is available inside data inside processed folder with name train_processed.csv. And let's assign it to one variable train_data is equal to this statement. You can see here, this folder we have created during our last stage, data preprocessing, that you can see over here, which contains two files, test_process.csv and train_process.csv, that you can see over here. Now let's save this file and using ilog, let's read all the features and I'm converting it to numpy x_train is equal to this statement. So here we are fetching independent variables from our training data. Same, let's fetch our dependent variable from the training data. And here again I am converting it to numpy array. And let's assign it to one variable. Train is equal to this statement. Now let's create instance of our random forest classifier with name CLF. You can use any. Now let's train our classifier on X-train and Y-train on our training data. Now let's save our model using pickle. So we have to use pickle.dump. Here we have to pass our classifier instance and let's open this file model.pkl in right binary. Let's save this code. Let me clear this. Again, we have to add this particular stage to our dvc.yaml file as our third stage of our machine learning pipeline. So for that, we have to write dvc stage add name of this stage model_building. Again, dependency, this file itself model_building.py. Another dependency data/processed folder that we have created during stage 2. Now you can see here, again here we are making connection between two stages, stage 2 and stage 3 through this dependency and output of this stage. As you know, model.pkl. How DVC will execute this particular stage? So we have to give Python src/model_building.py. Let's execute this code. You can see here. Let's check dvc.yaml file. You can see we have successfully added our third stage to our machine learning pipeline. Let me clear this and let's reproduce our pipeline using dvc space repro command. Done. So you can see after this particular stage, model building, model.pkl created over here, that you can see over here. Let's check. Let's visualize our pipeline using dvc space deck command. You can see here, we have successfully created our third stage, model building. You can see here, our pipeline, data collection, preprocessing and model building. And you can see this connection has been created because of dependencies that we have provided over here in this particular command that you can see over here. So now we have successfully created our third stage of our machine learning pipeline, model building. Now let's move on. As you know, we have successfully created 3 stages of our pipeline. Now let's create final stage of our pipeline, model evaluation stage, to evaluate the performance of our machine learning model, random forest classifier. Now let's click on this folder src and let's create new file with name model_eval.py. You can give any. Again, we have to import numpy as np. Also we have to import pandas as pd. Also we have to import pickle. Also we have to import json. Also let's import from sklearn.matrix. Let's import accuracy score, precision score, recall score, and F1 score. Also, let's read our test file from data processed test underscore processed.csv, this file, and let's assign it to one variable test data is equal to this statement. Again, here we have to separate independent variables and dependent variable that we have done over here. So let me copy and let me paste it over here to save our recording time. X test and Y test. Here test data. Here also. So here independent variables of test data and dependent variable of test data that we are storing inside X underscore test and Y underscore test. Now let's load our saved model. As you know, we have successfully created this model in our last stage, model building, that you can see over here. So this is our model with name model.pkl. So let's open model.pkl in read binary mode and let's assign it to one variable model. Now let's perform prediction using this saved model. On X test, let's assign it to one variable Y pred is equal to this statement. So we are storing predictions inside this variable Y underscore pred. Let's find accuracy score. So here we have to pass actual values and predicted values by our model, which is available inside Y underscore pred. And let's assign it to one variable X. Also precision score. Again, here we have to pass actual values and predicted values by our model. Let me assign it to one variable pre. Recall score. Again, actual values and predicted values by our model. Let me assign it to one variable recall. F1 score. Again, here we have to pass actual values and predicted values by our model. And let me assign it to one variable F1 score. Let's save our file. Now we are going to store this matrix inside JSON file. So for that, let's create Python dictionary and as a key ek and value ek, this value, this variable. Now again key precision and this variable pre that we have created over here. Recall. Here recall this variable F1 score, value F1 score. Now let's create JSON file. So open and we have to open matrix.json into write mode as file json.dump matrix underscore dict that we have created over here, this one, and file. Also let's set indent 4. Let's save our file. I am pressing Ctrl S. Now done. Why we have created this JSON file, I will explain you shortly. Now let's clear this. Now let's add our final stage model evaluation to dvc.yaml file, means to our machine learning pipeline. So again we have to use this command dvc stage add name of our stage model eval dependency file itself, which is available inside src folder with name model eval dot py. Again dependency model dot pkl. In place of output, here we can use parameter matrix. Here matrix dot json file that we have created over here. And how DVC will run this stage? Using this Python command by running this module model underscore eval dot py. Now let's execute this command. I'm going to press enter. Let's check this file. You can see we have successfully added this particular stage to dvc.yaml file to our machine learning pipeline. Let's clear and let's execute our pipeline using dvc repro command. Let's execute this command. Let's press enter. I think there is some spelling mistake here. Eval. Sorry for this. Let's execute this command. We have to change from here. Eval. Now let's clear this Also, don't forget to save this file, dvc.yaml file. And again, let's run our pipeline. You can see over here, we have successfully created our fourth stage for model evaluation. Let's clear this and let's visualize our pipeline. You can see over here, our 4 stages of our machine learning pipeline: data collection, data pre-processing, model building, and model evaluation. And you can see the chain, which is our pipeline that you can see over here. Now, why we have created this JSON file here? Because using DVC matrix show command, we can visualize our matrix. So you can see our matrix: accuracy, F1 score, precision, and recall, that you can see over here. That's why we have created this JSON file, this one, and you can see over here. And the file is created over here. Let me click on this. You can see over here. We can visualize our matrix by clicking on this file that just we have created and using this particular command, DVC matrix show, that you can see over here. You can see we have successfully created our machine learning pipeline using DVC, that you can see over here. So this way we can create machine learning pipeline using DVC. Hope all of you are clear with this. So in the upcoming videos, we will try to improve this project. Additionally, we will develop an API using Fast API for this project and deploy it on the cloud so that someone can use our API to perform predictions. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.